Okay, the point of this question was to make this less work for you by giving you the factored form already. Normally you're given like a giant rational function that you have to first factor using synthetic division, which takes a long time. So I gave you it in factored form already, so you would just get right into the analysis. The problem is that some of you still don't know how to look at this and determine the key features. Again, I'm giving you the key features that you need to find. Like I'll have that written on the board for you, so you don't have to memorize that. But one of the big unit questions was, why are vertical asymptotes, what just happened? Hello? Where'd we go? Oh, here we are. Okay, why are vertical asymptotes, why are those only on the bottom of the function, right? So let's actually box this in red and then find out where our vertical asymptotes are. So that's going to be vertical asymptotes, and then we're going to find holes. Okay, we'll do that in blue. And then we're going to find our roots. Those are our first three things that we look for. And we'll do that in green. Okay. So vertical asymptotes are only on bottom for a very important reason that you need to figure out. That's one of the big unit questions that we've discussed. Okay, so vertical asymptotes are only on bottom. So we see that x minus 1 and x plus 1 are both only on bottom. So those are going to be our vertical asymptotes. Those are going to happen at x equals 1 and x equals negative 1. Holes are on top and bottom, and we cancel it from our function. So our hole is going to be happening at x equals negative 2. We have to find the y value. We'll come back to that in a second. And then roots are only on top. So we have one right there, one right there, at x equals 3, and that is going to bounce. And then we have 1 at x equals negative 4. Okay. Now, to find the y value of the hole, we have to take that negative 2 and plug it back into the function with the factors canceled. So we get 3 times negative 2 minus 3 squared times negative 2 plus 4 all over 2 times negative 2 minus 1 times negative 2 plus 1. Okay, so then that is going to give us 3 times negative 2 minus 3 is negative 5, so that squared is 25 times 2, and then over 2 times negative 3 times negative 1, which gives us 75, 150 on top over negative 6, which simplifies as negative 25. Okay, back. Sorry, I had to take a break. So we were at that. We found the hole is at the y value is negative 25. So we come back in here. Let's just point it back. So we just did the simplification. So it's negative 25 is going to come up here. Dang it. Okay, so it's positive 20. It's positive 6 because. So this is negative 3 times negative 1, which becomes positive 3 times 2 is positive 6, and this is positive 25, which makes this negative 2 comma 25. Okay, so we know that there's a hole right there. Vertical asymptote, holes, and roots. Okay, the next thing we need to look for is we need to find the y-intercept. Now, here's the thing with the y-intercept. I am going to give you the factored form, but it's easier to find the y-intercept when it's not in factored form. So on the actual test, I'm also going to give you the unfactored form. So let me just look that up really quick so you can see what it is in this case. Okay, back in action. So here it is. This is if you take this function and factor it, then you have the rational function. You have the factored function right here, which helps us find some stuff. But it turns out that the y-intercept is easier to find if we can have it in unfactored form, because then we plug in 0 for x. That's what it is. That's what the y-intercept is where x equals 0. So what happens then when we plug in x equals 0 is all of this that has an x on it is going away because we're multiplying it by 0. We're just left with y equals 216 divided by negative 4, which is equal to 54, negative 54. Okay, so all that did was it told us the y-intercept. It intercepts the y-axis at 0, comma, negative 54. Okay, so that's all we can do for now until we sketch it. We can also determine that there is no horizontal asymptote, because if we look here, we have 1, 2, 3, 4 factors on top, and we have 1, 2, 3 on bottom. The degree is bigger on top. It's 4 on top and 3 on bottom, so there is no horizontal asymptote. On the test, you may have a horizontal asymptote, so you're going to want to review your horizontal asymptote rules. There's only 3 of them. It's not too bad, okay? In this case, no horizontal asymptote. So this is all we can do for now until we sketch it. So let's start sketching some stuff now. So we draw our coordinate axes. Let's put our vertical asymptotes in first. We have one at 1 and negative 1. So here's one of them. And then at negative 1. All right, and then we have a hole at negative 2, comma 25. So we'll just come up here and say we're at negative 2, comma 25. And then we have roots at 3 and negative 4. So 2, 3, negative 3, negative 4. Okay, so we have roots at 3. And we know that that's going to be a bouncer. And then we have one at negative 4, and that one's going to cross. Okay. And then we have our y-intercept down there at 0, comma, negative 54. So we'll just come all the way down here. And that's at 0, comma, negative 54. And then no horizontal asymptote to worry about. Don't worry about finding the slant asymptote. So now all we have to do is determine the positivity and negativity. This is a little bit tricky because it kind of depends on the situation. In this situation, we have to go in each, well, every time you have to look in each section and determine it. But what we see is that this one has a hole up here, so the function must go through here. It must cross through here at some point. And it also must cross the x-axis at some point, but it never comes back up or anything. It only crosses at one time. So we know that this thing must be positive over here, and then it crosses down and becomes negative. Again, because it must cross through the hole, and then it must cross through the x-axis. Okay. Now over here, well, it has to go through the y-intercept down here, and it doesn't cross the x-axis again in this section because there's no root there. So we know that this thing is negative over here every time because it never crosses the x-axis. Okay. The only one we're not sure about is over here. We know this is bouncing, but we don't know if it's going to come down and bounce like that or if it's going to come up and bounce back down. So what we have to do is we have to plug in one of these points. Let's plug in 2 to the factored form. So we're going to come up here. We're going to plug in 2. We get 3. Okay, x equals 2. We get 3 times 2 minus 3 squared. That's 3. 2 plus 2. 2 plus 4. On bottom, we're going to have 2 times 2 plus 2 times 2 minus 1 times 2 plus 1. And the thing is, all we have to do is determine, is this positive or negative? So what we see is this term is going to be positive because it's squared. This is positive. That's positive. This is positive. This is positive. This is positive. Okay, so we have positives all around. So this thing is going to be positive at x equals 2. So again, we plugged in 2 because 2 is a point in this section that we don't know anything about yet. So we plugged it in. We found out that the function is positive there. So then we know that this function must be positive, come down, bounce, and then bounce up to positive again. And that is the full analysis done.